Hi, we are
Robotitans.
First of all, we're gonna clarify everything that we've done so far, including the coding, robot design, even the attachments. As in the rules, we designed the robots with 4 motors, including 2 big in the upper part, and we used it for the attachment because it's stronger and more effective. And the small motors, we use it for the movement because it's faster and more reliable in the movement. And we used over here 2 light sensors to reduce the amount of failure that we may face due to the light performance. And the last thing is the hub. Moving on to the major problem that we faced, which is facing the movement. The movement wasn't moving forward because of this white wall, so we substituted by these black wheels. As you can see, the goat, which is our robot name, we designed it as a cubic. Why? Because it is more flexible and balanced. And as you can see, there are whole clips all over the robot, so we can attach the attachments easily and more flexible. Moving on to the first attachment with my friend Turkey.
We used this attachment for solving the whale mission. The yellow part will hit the whale from down, and the fish above will fall down into the whale's mouth. In addition, this attachment is passive, which means it doesn't need any motor to use. Give the robot. We add this tail and stick it up behind the robot. It was my friend's idea, Sultan, and we use this to finish for us 2 missions, the shark and the one beside it. And this is a simple attachment. We will put at the side of the robot to raise up the I think ship of this mission right here. Moving on to Sultan.
We've designed this great attachment to collect items from all over the map. And as you can see, as soon as an item gets in, these rods stop it from getting out. Moving on to my friend Muayyad.
Okay, and we do this attachment to did this mission, put it up, and we can put it down like this mission. Okay, and from here we can move the motor, and it's heavy and wide shape. And this attachment, we do this mission, lift it up, and we do 2 motors to be stronger.
This masterpiece that we've done can solve for us 2 missions, which is the solar discovery and also this one over here. You may ask us why we did the Y then X then Z axis instead of the Y then Z. It's because so we can get more flexibility and reducing the amount of failures we may face. Moving on to the coding with my friend Tal.
We've designed these blocks in accordance to our robot, so we can make sure that our robot works in the best way possible. As you can see in the first block, the gyro straight. What this block does is that it makes the robot moves forward, and as it moves forward, it adjusts its yaw angle to 0, making sure that it doesn't slip or get off track. As you can see in the first command, it will set the angle to 0. It will reset the timer because we measure the distance by seconds, and as soon as the timer is greater than the seconds, it will stop. Moving on to the next block, which is it's an increment. It's an increment. What this increment does is that it triggers 2 missions at the simultaneously to save time. Moving on to Muayyad.
And here is the rotational distance. Rotational distance uses the gyro sensor to reach a target currently and faster using the game. And here is the tail lift. The tail lift uses the gyro sensor to turn.
Turn right is the opposite to the left. In a simple and easy way, it will increase the speed of the left wheel and decrease the speed for the right one.
The last block that we have is the proportional distance that you can see over here. The proportional turn is like this simple turn, but it is more efficient and faster, and also it uses the gyro turn. Thanks for listening. That's what we had so far, and we promise you that we will improve in the competition date and get everything.